Today we're going to be talking about the Earth's layers, and our focus question is what are the characteristics of Earth's crust, mantle, and core? So first let's talk about how we have learned about the Earth's interior. There's two main types of evidence we've used. The first one is direct, which is from rock samples, so it's something like this on the right. And the second is from indirect, is from seismic waves and being able to measure those types of seismic waves and the way that they move through the core. Temperature. So the further you move into the Earth, the hotter it gets. For every 40 meters that you descend, it gets up 1 degree Celsius hotter. So you'll notice that as the depth of 0, if it shows 0 degrees, as you go into the Earth, once you reach about 3,000 kilometers, you'll notice it's about 4,000 degrees Celsius. Pressure and density. The further you go into the Earth, just like temperature, the higher the pressure and the higher or greater the density. This is the same as when you're swimming in a pool and you swim to the bottom. The pressure changes, it makes your ears pop. You may have also experienced this on a plane. The lithosphere. The lithosphere is an area of the layers that encompasses both the crust and the uppermost part of the mantle. So you'll see here in this that the lithosphere is partially the crust and partially this uppermost part of the mantle. The crust is a layer of solid rock that includes both dry land and ocean floor. The composition is very different depending on if you're going through the ocean or through the dry land part of the crust, but they are still part of the Earth's crust. The uppermost mantle is very similar to the crust, and this with the crust forms the actual lithosphere. Underneath this part of the crust is the convecting mantle. So below that part, it's softer than the rest of the mantle, and it has a tar-like consistency that moves really slowly but still flows around. It's still very hard. If you were to kick it, it would still hurt. The dense metallic core. This is a dense ball of solid metal, which is the inner core, surrounded by a layer of molten metal, which is the liquid outer core. The two of these together are mostly made up of iron and nickel, and the outer core is what creates the Earth's magnetic field. Convection currents in the lithosphere. So the lithosphere is divided into separate plates, which move very, very slowly in response to the convection currents in the mantle. Heat from the mantle and the core creates these convection currents. And this looks something like this animation that you'll watch here. So you'll notice as the convection currents occur, the plates of the lithosphere tend to move around. Let's watch it one more time. So as you saw in that process, the convection currents spin around, and this tar-like consistency of the mantle is then moved around, and the lithosphere plates move slowly on the surface of that. So let's do a couple things just to get some practice. This is the part of the Earth that has the least amount of pressure. This would be the Earth's crust. This is the part of the Earth that has the highest temperature. This would be the Earth's core. This is the part of the Earth that moves very, very slowly. The mantle. Part of the Earth that is described as a solid metal ball. This is the inner core. Part of the Earth that has the highest amount of pressure. Also the core. Part of the Earth that contains the upper mantle and the crust. This is the lithosphere. And the type of evidence we use to learn about the Earth's layers that uses rock samples. And we would consider this direct evidence. Go ahead and move on to your interactive worksheet for the day, and then you may complete your exit ticket.